Okay. So, hi, good evening to all of you. I hope that everyone is fine in their place. So, here we are with the third lecture of laws of motion. I am not mentioning the lecture number here. So, okay, there is no problem with that, please. So, I think all of you are doing good. Hmm? So, as of now, we have discussed a lot of thing in laws of motion. So, if I just want to brief you about this. So in the briefing of it, we have discussed about the laws of motion specifically, the laws of Newton laws of motion. Then after we have discussed about the concept of momentum and the conservation of it. After that, we have also throw some light on the impulse. What is impulse? Practically also, and we have did a very good observation about it with respect to the FT graph. We have solved a numerical also that FT graph. Okay. FT graph is related to the impulse. The area under this curve gives you the impulse that we have discussed in the previous lecture. What it? What about else? We have also discussed about the type of force, about type of forces, and two very important condition we have discussed in the previous lecture about the ideal string and about the ideal pulley. Isn't it? सभी को clear है? Ideal string and ideal pulley के बारे में we have talked about in the previous session. Now we are going to utilize these all concepts to solve the numerical expectancy in this question in this chapter. Okay. So I think all of you are with me. Let's just get started with the very first question first of all. So question is in front of your screen. Find the contact force because I have told you about the normal reaction force. I forgot to mention in the first slide. We have also talked about the free body diagram in the previous session, and based on that I have introduced two type of force in front of you, which is the normal reaction and the weight force. So according to that, find the contact force between 3 kg and 2 kg block as shown in figure. तो ये जो आप देख रहे हो सामने क्वेश्चन, इट इज बेस्ड ऑन द नॉर्मल रिएक्शन एंड फ्री बॉडी डायग्राम. ठीक है. सो यू हैव टू टेल मी व्हाट इज द नेट फोर्स acting in between these two blocks, 3 kg and 2 kg block. We have to find out the contact force. Got it? Now for that, for sure, I know that you are also able to do it. Let's just start solving it. देखो. The very first thing that we are going to do here is draw, and to solve any question in NLM, so the first step you will take, draw the FBD. ठीक है. तो सबसे पहले हम क्या करेंगे, FBD ड्रॉ करेंगे. इफ यू टॉक अबाउट द FBD ऑफ 3 kg ब्लॉक, दिस इज द 3 kg. ठीक है. I'm not mentioning this one, the bottom side. First of all, we know that the weight force acting in the downward direction, which is nothing but 3 into g, because the weight force is equals to mg and the mass given here is 3. So that is why the weight force which is acting in the downward direction is 3g. Upward side mein, if you will see, there is a force, normal reaction by the ground, which we will take it as n1. Got it? Now there is a force acting from the left side, which is F1, having a magnitude of 100 Newton. Got it? Similarly, to compensate this F1, this is making this block A is making contact with block B. This block A is making contact with block B. So there must be a contact force perpendicular to the contact surface. So that force, अब ये 3 kg ब्लॉक पे कैसे किस तरफ लगेगा, ऐसे लगेगा या फिर ऐसे लगेगा. अब देखो, how 3 kg block will experience this normal reaction, it is the question to ask. देखो, 3 kg block try to push this 2 kg block inside. ये 2 kg ब्लॉक को क्या करने की कोशिश कर रहा है, कंप्रेस करने की कोशिश कर रहा है. तो इन द सेम वे, by Newton third law, 2 kg block will also try to compress it. So this force will be experienced by this block 3 kg. ठीक है, क्लियर हुआ? So this is the force experienced by 3 kg, and let's say this is the different normal reaction, so we will assume it as N2. Got it? Now, if you will see here, we can directly relate this vertical direction forces because there is no motion possible in the vertical direction. So we can say that N1 should be equals to 3g, and if you put the value of g as 10 meter per second square, this will become 30 Newton. So this is the normal reaction from the ground. Notice the contact, because we have to find out the contact force. Although this is also a contact force, but this contact force is between 2 kg block and ground. Got it? But we are interested in this N2. So horizontal forces, if you would like to balance here, it will not be balanced because you do not know what is the magnitude of N2, and what is, you know clearly the F1 is 100 Newton, but you do not know what is the magnitude of N2, कि N2 कितना फोर्स है. तो अगर N2 भी 100 न्यूटन है तब ये फोर्स तो बैलेंस हो, लेकिन अगर N2 100 न्यूटन नहीं है, देयर मस्ट बी सम एक्सेलरेशन इन द सिस्टम. गॉट इट? Similarly, draw the FBD for 2 kg block. So for 2 kg block, if you will see clearly here, again there will be a normal reaction. Let's say N1 dash downward, there will be a mass 2g. This side we are having a force of 25 Newton, and this will be the N2 to compensate this. ठीक है. Now how to proceed in this question? How to proceed? अभी हमने FBD से ये तो क्लियरली पता करा लिया कि N1 डैश की वैल्यू भी 20 न्यूटन होगी, एंड दीज फोर्सेस आर नॉट बीइंग इक्वल. ठीक है ना, इनके बारे में हम कुछ भी अभी नहीं बोल सकते. तो व्हाट वी आर गोइंग टू यूज हियर, द सेकंड थिंग इज द कॉन्सेप्ट ऑफ सिस्टम वी आर गोइंग टू यूज. कॉन्सेप्ट ऑफ सिस्टम मैंने आपको बताया भी था इन द प्रीवियस लेक्चर, हाउ टू यूज दिस. तो फर्स्ट ऑफ ऑल हम क्या करेंगे, इन दोनों को ब्लॉक्स को एक सिंगल बॉडी अज्यूम करेंगे, हैविंग अ वेट ऑफ 5 kg. अब आप पूछोगे कि 5 kg कैसे, तो 3 kg plus 2 kg will become 5 kg. Now if you will see, externally there are two forces, F1 and F, because all the internal forces will vanish out. We do not consider the effect of internal forces when we assume this as a system. I have told you in the previous session. Now we clearly see that here we have applied 100 Newton force, and here we have only applied the 25 Newton force, which means the forces are unbalanced. So these external forces are unbalanced in nature. Okay, so there must be a reaction, or there must be a external force which we will see F external, that should be equals to mass into acceleration of the system. The system will move together. F external, we will say this side wala force we will take positive, and this side wala force we will take negative. So here we have applied 100 Newton positive minus 25 Newton equals to mass, which is 5 kg. Acceleration we have to calculate. This will become as 75, 5 into A. So A will become 15 meter per second square. Now what is the use of this acceleration? Now we know that if the whole system is moving with acceleration 15 meter per second, these individual block will also move with this acceleration 15 meter per second square. 15 meter per second square. Got it? So if you apply the equation from any of these, so you can say, let's just apply for block 2. Always remember that in the direction of force, when you are applying the Newton's second law, in the direction of acceleration, whatever the force is present, you have to take that force as positive. So if you will see, acceleration is towards left, sorry, towards right, N2 is also towards right. So we will write is that N2 positive minus 25 Newton is acting in the opposite direction of acceleration. So N2 minus 25 will be equals to mass of the system, which is 2 kg, multiplied by the acceleration, which is 15. So N2 here will become 30 minus, sorry, 30 plus 25, because this will coming here as positive. So N2 is coming out as 50 55 Newton. This is the value that we are seeking for. If you apply the same for this one, then also you are going to get the same result. Okay, you can try it right now. देखो, F1 is in the direction of acceleration, so we will take it as positive, minus N2 is in the opposite direction of acceleration, considered negative, is equals to mass is 3 kg multiplied by acceleration is 50. So if you will see here 100, this will come this side to become negative. 15 3 is a 45. So N2 will become here 55 Newton again. So both of them are giving you the same results. And that's why we can conclude that normal reaction in the contact are equal and opposite to each other. Okay. I hope this question would be easier for you to understand. If you have any kind of issue, in any kind of doubt in this question, you can ask me right now. Anyone, any kind of doubt in this question? No one? Okay. Now let's try to solve this. I'm giving you 1 minute to solve this. Apply whatever you think you have learned so far. The particle moves in xy plane under the influence of a force F vector such that its linear momentum is pt. देखो यहाँ पे linear momentum vector is given to you. P vector is cos kt. I'll simplify it for you. Cos kt I cap minus sin kt j cap. This is the momentum vector. If k is constant, the angle between F vector and P vector will be. So to calculate angle between any two vector from the vector algebra, we can say the angle between any two vector will be nothing but the dot product between these two vectors divided by the magnitude of these two vectors. Got it? This is the formula or the concept to calculate angle between two vectors. Now we have the P vector. How to find out the F vector? How to find out the force vector here? किसी को कुछ आ रहा है दिमाग में? फोर्स वेक्टर हम न्यूटन सेकंड लॉ के अकॉर्डिंग क्या लिख सकते हैं? पी एफ वेक्टर इज नथिंग बट डीपी बाई dt. We just have to differentiate this p. So differentiating p with respect to t, you will have dp vector by dt. Now those who have problem with the differentiation, let me know in the chat box. देखो, when you differentiate this, differentiation of cos theta will be minus sin theta. So it will be minus sin kt, and since inside also there is a function of time, so we will differentiate it again. So differentiation of kt will gives you k. So I will write it like minus k sin kt I cap minus sin का differentiation will be cos kt. ठीक है? And again k will come out. This is j cap. This is nothing but the force vector. It is minus k sin kt I cap minus k cos kt j cap. Okay, minus k you can take common also. So here if we want to measure the angle between them is cos theta is equals to f vector dot p vector divided by magnitude of f vector magnitude of p vector. ठीक है, चलो पहले मैग्नीट्यूड कैलकुलेट कर लेते हैं. तो मैग्नीट्यूड ऑफ पी वेक्टर विल बी नथिंग बट स्क्वायर रूट ऑफ component of I cap plus component of j cap का square individually. So cos square kt plus sin square kt. This will result as 1 because this is the identity. Cos square theta plus sin square theta is equals to 1. Similarly, if you do for f vector also, you will get the same results. This is sin square kt plus cos square kt. This is equals to 1. Okay. Now f vector dot p vector. F vector is minus k sin kt minus k sin kt I cap minus k cos kt j cap. This one dot product with p vector. P vector is cos kt I cap. Just a second. Cos kt है ना? Cos kt I cap minus sin kt j cap divided by 1 into 1 because the magnitudes are 1 and 1. तो देखो डॉट प्रोडक्ट भी कैसा होता है, जो सेम कंपोनेंट है आई का आई के साथ होगा और जे का जे के साथ विद देयर सिंबल. तो इफ यू डू सो it will become minus k sin kt into cos kt sin kt cos kt, and this will become minus k into minus 1. This will become positive. ठीक है, minus k minus will become positive. तो cos kt sin kt again k sin kt cos kt divided by 1. अब देखो this is the same quantity in negative, this is the same quantity in positive, so they will cancel out. So ultimately cos theta is coming out here is 1, sorry 0, and theta is 0, cos theta is 0 is when theta will become pi by 2. ठीक है, so this is the answer. किसी को कोई डाउट है? anyone that is present here? JNV Shimoga student, JNV Kolhapur students, Haveri, Anjum, Navodyan Siri, Bindu, Nidhi. Any doubt, guys? ठीक है, today we are going to learn very important topic. ठीक है, so stay tuned. Now this question: a body of mass 4 kg experience two force F1 and F2. The acceleration acting on the body is. Simple question, and these are the previous one also. The previous one also the JEE main question. Okay, so JEE main 2023, 2022. Now here are two force vectors are given to you: 5i cap plus 8j cap plus 7k cap, and F2 vector is 3i cap minus 4j cap minus 3k cap. ठीक है, mass of the block is given as 4 kg. We have to find out the acceleration acting on the system. Now we know that F net or F external should be equals to mass into acceleration vector. Hmm? Now F net is nothing but the vector sum, so we will put it according to the dimensions given here. Okay, so it is 5i cap plus 8j cap plus 7k cap minus 3i cap minus 4j cap minus 3k cap is equals to, this is F1 vector, this is minus F2 vector, mass into acceleration. Now 5 minus 3 will become 2i cap. 8 minus, अब देखो this is minus already, minus into minus will become plus, so 8 plus 4 which is 12j cap. Again 7 is plus, minus minus plus, 7 and 3 will become 10, so 10k cap is equals to mass 4 kg into acceleration vector. Now divided by 4, acceleration vector is 2i cap by 4 plus 12j cap by 4 plus 10k cap by 4. ठीक है, this is k cap. This is 1 by 2, 4 3 is 12, and this is 5 by 2. The acceleration vector here is, we can say I by 2, 1 by 2 times of I cap plus 3j cap plus 5 by 2 k cap. ठीक है, if you multiply and divide by 2, that's when we can do also here. So if you do so, it will become 1 by 2, sorry, 2 we have multiplied inside and 1 by 2 we have kept outside. It will become I cap plus 6j cap plus 5k cap. This is the acceleration vector. ठीक है, क्लियर है सभी को? किसी को कोई डाउट है? एनी प्रॉब्लम इज हैविंग देयर in your internet connection, or my voice is not coming to everyone? Anyone can clarify this, please? Because most of you are leaving the class. Why the reason is that? Can anyone mention you? Is the screen is not visible, or I'm not audible? Bindu, Siriem, JNV Kolhapur, JNV. Anyone? Okay, no issues. That's what I'm not expecting also. ठीक है, चलो. This one, this question can also be solved down here. A 5 kg block has a rope of mass 2 kg attached to its underside, and a 3 kg block is suspended from the other end of the rope. The whole system is accelerated up is 2 meter per second square by an external force F naught. What is the F naught? What is the force on the rope? What is the tension at the middle point of the rope? Okay. Clear है सभी को? This question we will discuss in the next class after discussing the concept of today's class. ठीक है ना? Because it might be having that we can not have any time, sufficient time to discuss these concepts. So I want to introduce them first of all. The first concept is concept of pulleys and mass system. Now, first of all, ideal pulley and ideal string we have revised out. Ideal pulley is that which is having zero frictional value. There is no friction on the pulley, and the pulley is massless. Okay. Now the same concept here when the pulley is fixed. So you will find these types of situations. This is the pulley and we have fixed it out with some hinge or any other support. And there are two sides. One is having a mass, another one is having a different mass. So this is M1, this is M. Now how to approach in this problem? How to approach these types of problem? First of all, if there is a string attached to these block which is passing over the pulley, first of all we have to decide what is the tension in it. So the first question I would address, tension in the rope. ठीक है? Would it be same or would it be different? So how to approach that? So first of all is, see, this pulley is ideal pulley and this pulley is fixed also. So if the pulley is fixed, the acceleration on both the side, because they are different masses, and let's suppose that M1 is greater than M2. So definitely this force will moving downward because it is heavier, and so this block will move up. So if the pulley is fixed, सबसे important point है पहला, if pulley is fixed, then acceleration of both side will be same. ठीक है? तो जो भी acceleration होगा on both side, it would be same. Suppose the acceleration here is a, so here also, although the direction will be opposite, but the magnitude wise they are same. ठीक है? Now, the second concept is about the tension. Actually, it is the first one. Tension would be same as long as the same string is passing over. ठीक है, जब तक सिर्फ एक ही स्ट्रिंग है जो कनेक्टेड है ब्लॉक्स के साथ और वट एवर द सिस्टम इट इज, तब तक टेंशन इन द रोप विल रिमेन सेम. ठीक है, सो हियर in this situation most of the question will ask you about the acceleration of blocks. So how to drop down that, how to approach? So we will analyze according to the FBDs. So first of all we will draw the FBD of separate blocks. Now let us draw the FBD of M2. So we know that M2G, which is the gravitational force, or you can say the weight force acting in the downward direction. Upward there will be a tension because this block is pulling down. It is trying to stretching this rope. The stretch this rope will also apply a force in the upper direction, which is tension. Now, as the system, if you will see, this block is moving up with an acceleration. Hmm? So I have told you that whatever the force is in the direction of acceleration, you have to consider that force as positive. So T minus M2G should be equals to M2A, mass into acceleration. This is the net force is equals to mass acceleration, mass into acceleration. And since we are observing only M2, so that's why we kept M2 here. Okay. So this is the first equation. Now, FBD of the another block, which is M1. Downward side में there will be a force M1G. Upward side में there is a tension force. But the system is moving downward, so the direction of acceleration has changed. So that we have to consider M1G as positive minus T is equals to M1A, equation 2. If you just add them, equation 1 and 2, you just cancel out the tension and you will get M1G minus M2G, which is equals to M1A plus M2A. And finally, we can write it as M1 minus M2 upon M1 plus M2 into G is equals to the value of acceleration. This is the value of acceleration in this system, if you will see. Okay? So this is how we will use this approach to write down the equation. So first of all, we have to identify the tension on both sides of the rope. Is it same or not? When it will be same? Until and unless the string is same. Okay? The same string is connected over the different blocks. In that case, tension will remain same. If the string change, the tension will change. Got it? Second thing, we have to identify the acceleration of both the block. Would it be different or would it be same? So it will be same if the pulley is fixed, because in the case one we are discussing when the pulley is fixed. So acceleration on both the sides of the system will remain same. But it is same in terms of magnitude, in terms of direction it is opposite. ठीक है, चलो. One more situation I'll analyze here. Suppose this is a rigid support and here we have a hinge. To that we have fixed a pulley. There is a block of mass M1. Here we have connected over the pulley with the help of a string, and this is the another block M2. Now, here in this situation, the motion will only possible if M2 is greater than M1. Otherwise, the system will remain in equilibrium. Okay, system will not move anywhere. So if you analyze this, how to approach? First of all, we draw the FBD of M2 block. And before that also, we have to identify the tension. Would it remain same or different? So you can see the same string is connected over M1 and M2 over the pulley. So we will say the same tension will be there. What about the acceleration? So see the pulley is fixed or not? Yes, pulley is fixed. So acceleration on both the block will remain same. So if m2 is greater than m1, m2 will pulling this m1 block in the downward direction. So m1 will have an acceleration in this way, and m2 will have an acceleration in the downward direction. Got it? Now just apply the formulas here. Here, when we draw the FBD of M1 block, you will observe something new. So first of all, FBD of M2, FBD of M2 block. देखो, M2 we have kept here. This is the M2. Downside में there will be a gravitational force. You can say the weight force M2G. Upside there is only tension, and the system or this block is moving downward. We can say with an acceleration A. So what will be the Newton's second law equation? M2G minus T would be equals to M2A. This is equation number one. Why M2G is positive? Why tension is negative? Because M2G is in the direction of acceleration. Tension is in the opposite direction of the acceleration. Okay? Chalo. This has happened for M2. Now try to do the same for M1. This is M1. The gravitational force M1G downward direction, but there is an upward force also, which is the normal reaction, because this block is making contact with this support. Got it? Although this will play no role here, so that's why it will play came into the picture only when this surface is having some friction. Okay? This side we have a tension force which is constantly pulling this block in the downward direction, and only this force is present. So we are applying the equation in horizontal direction. So we can say that T, which is the only possible force in the direction, is equals to M1A. Okay? M1 into A. This is equation number 2. Although if you want to write, it's not a problematic thing. You can write N is equals to M1G. There is no problem at all. Put the value of this tension in equation 1, or you can say do the subtraction of equation 1 and 2. So what you are getting here, I'm writing down here. I'll using the different ink, sorry. So M2G minus M1A is equals to M2A. So here, what will be the acceleration finally? It would be M2G over M1 plus M2. Got it? This is the acceleration. If you see very carefully, this acceleration is directly proportional to the mass M2. Okay, na? So you can directly use this formula that take up this mass divided by the sum of the mass multiply by the gravitational acceleration. And if you see the tension, it depends on M1. So M1G, sorry, it depends on the product of both the masses. If you put the value of acceleration here, it will become M2G upon M1 plus M2. This is the tension. And in the first case, this is the acceleration. Got it? So this is what we have covered here. Now, I'll give you a very easy situation to narrow down here. Suppose there is a fixed pulley and this is a block attached here, and we have a rope. In this side there is no mass. This is pulled by some men or a machine, okay, with a pulling force. So in that case also, if we will see, tension will develop over the same. This tension is nothing but equals to the pulling force. So we can write it down as here. Pulling force is equals to the tension developed in the string. In the string. Okay, क्लियर है सभी को? चलो, नेक्स्ट केस इज व्हेन पुली इज नॉट फिक्स्ड. ठीक है, when pulley is not fixed, or we can also term it like this, movable pulley. Movable pulley. ठीक है, देखो मूवेबल पुली का केस इज स्लाइटली डिफरेंट. सपोज we are having a pulley here. This is the situation. Let's say this is the pulley which is moving with some acceleration AP, and here are the two rope which is, or two masses, let's say M1 and M2, attached to a string which is passing over this pulley, having an acceleration in the upward direction. Although we are considering that mass of pulley is not there. ठीक है, क्लियर हो, आइडियल पुली है तो मास विल बी नॉट देयर, only the masses are there is M1 and M2. And suppose we will take a reference. So this is the reference line. Reference line. Let's say the height of this M1 block from this reference line is M1. M1 block का height is Y1. M2 block का height is Y2. ठीक है, and the center of pulley is also at a distance of YP. ठीक है, क्लियर है. Now radius of the pulley is small r. Radius of pulley is equals to small r. Now the concept behind this movable pulley, how to drop down this, how to solve, or what is the approach for this, is very simple and yet very logical also. The concept here is, since we are using an ideal string, so the length of the rope or the string, rope slash string, will not change. ठीक है, and that is the same concept we are going to use in this situation. ठीक है, देखो कैसे. If I ask you what is the length of this rope, can anyone tell what is the length of this rope? Let's say the length of the rope in this situation is L. ठीक है, considering the length of rope or string is small l. ठीक है, so how to write this? Small l is equals to, stay focused here. ठीक है, stay focused. Small l, how we should write? What is the length? Length is only this part, this yellow part from M1 to M2. ठीक है, how to write this? We can write L is equals to Y1 plus Y2, sorry, this is YP ना, YP माइनस, अगर मैं YP में से Y1 घटा दूं तो मुझे ये वाला लेंथ मिलेगा, ये वाला. ठीक है, तो YP माइनस Y1 प्लस, अगर मैं YP में से ये वाला लेंथ घटा दूं Y2, तो मुझे कौन सा लेंथ मिलेगा? ये वाला लेंथ मिल जाएगा. ठीक है, तो आई कैन राइट YP माइनस Y2. अब दिस इज अ वेरी इंपॉर्टेंट क्वेश्चन. ये भी तो है ना, ये वाला, दिस, ये पुली है इन अ बिगर पिक्चर, आई टेल यू. तो ये रोप ऐसे ही तो जा रही है ना पुली के ऊपर से, तो ये वाला लेंथ भी तो काउंट होगा, ये वाला, ठीक है। हाउ टू राइट दैट? दिस विल नथिंग बट, since pulley is circular in shape, so it is the half of the circumference, which is nothing but pi into r. ठीक है। Now look over the concept. Concept here is that pulley will not change its length, because ideal pulley, sorry, ideal string है, so that will be inextensible. So if I say that dl by dt, which means change in length with respect to time, it's not possible. So I have to differentiate all of this. D by dt of 2yp, because yp and yp will become 2yp, minus y1 minus y2 plus pi r. Now dl by dt is 0, because string will not change its shape, so it will coming out as 0. This 2 can be out, and this will become dyp by dt minus dy1 by dt minus dy2 by dt plus d pi we can take out dr by dt. अब देखो, dr by dt will not also change, will not also change, because r is nothing but the radius of the pulley. तो radius of the pulley थोड़ी change करेगा over the time, so it will also be 0. Now what is this yp by yt? dyp by dt, देखो, pulley is moving with up with some acceleration ap, तो dyp is nothing but the length of the pulley from the reference line. तो yp by yt क्या हुआ, सॉरी, dyp by dt क्या हुआ? चेंज ऑफ दिस लेंथ with respect to time, which is nothing but the velocity of pulley. So 2 times of velocity of pulley minus dy1 is nothing but the length of this m1 block from the ground. So it is changing the length of m1 block from the ground will give the velocity of m1 block, and since v2 will be in the velocity of the second block. Okay. Again, if you will differentiate, first of all, I'll write it in a slightest manner. So it will coming out as 2 times of Vp is equals to V1 plus V2. And this is the vector sum, you can say. Okay. This is the really important formula to note down. Okay. This is very important. Now, if we just differentiate this, I'll do here 2 times of Vp V1 plus V2. If just differentiate it with respect to time, so 2 dVp by dt is equals to dV1 by dt plus dV2 by dt. So this will become 2 times of acceleration of pulley is equals to A1 acceleration of block 1 plus acceleration of block. इसका मतलब क्या हुआ? Whenever the pulley is moving, तो उसके अक्रॉस जो भी ब्लॉक्स हैं उनका जो एक्सेलरेशन होगा दैट वुड बी डिफरेंट, ठीक है, दैट वुड बी डिफरेंट एंड गिवन बाय दिस वेलोसिटी. नाउ यहाँ पे भी हम कुछ केसेस डिस्कस करेंगे. इफ both the blocks, because you have to put according to the sign, ठीक है, if both blocks are moving up, अगर दोनों के दोनों ब्लॉक पुली के साथ ही ऊपर जा रहे, ठीक है, ये m1 ब्लॉक हुआ, ये m2 ब्लॉक हुआ, दिस इज ऑल्सो मूविंग अप, दिस इज ऑल्सो मूविंग अप, एंड पुली इज ऑल्सो मूविंग अप, ठीक है. तो इस केस में जो भी पुली की एक्सेलरेशन के डायरेक्शन में होगा, पुली इज मूविंग अप, this is also moving up, this is also moving, so whatever the acceleration lying in the direction of acceleration of pulley, you have to take it as positive, a1 plus a2. बट सपोज एक ब्लॉक अगर ऊपर जा रहा है और एक ब्लॉक नीचे जा रहा है, सपोज दिस वन इज मूविंग डाउन एंड दिस वन इज मूविंग अप, ऐसा भी हो सकता है, ठीक है. तो इस केस में क्या होगा? अगर आप देखो, इस केस में क्या पॉसिबल है कि ये जो है A1 को you have to take it as negative because it is the opposite in the direction of acceleration of pulley. ठीक है, तो यहाँ पे मैं इक्वेशन कैसे लिखूंगा, 2 times of acceleration of P is equals to A2 minus A1. ठीक है, third case that is not possible, I like to write here AP, this block is also moving down and this block is also moving down, so this will not possible, ये केस पॉसिबल ही नहीं होगा. ठीक है, दिस इज नॉट पॉसिबल. ठीक है, अब अगर इस सिचुएशन की बात करो, इस क्वेश्चन की अगर आप बात करो, तो यहाँ पे आप देख सकते हो ये जो ब्लॉक है, लेट मी चेंज द कलर, ये जो पुली है ये मूवेबल है, देखो, क्योंकि जैसे ही ये ब्लॉक नीचे की तरफ जाएगा ये पुली ऊपर की तरफ आएगी, तो ये पुली कैसी हुई, मूवेबल पुली. बट ये पुली फिक्स्ड है. अब देखो ये पुली फिक्स्ड है, शुरुआत से एनालिसिस करते हैं, ये पुली फिक्स्ड है, तो एक्सेलरेशन दोनों साइड का क्या रहेगा, सेम. तो अगर मैं इसका एक्सेलरेशन A1 ले लेता हूँ और इसका एक्सेलरेशन भी A1 ही लूंगा, बिकॉज ये वाली पुली फिक्स्ड है, तो इसके दोनों एंड्स पे एक्सेलरेशन विल बी सेम. ठीक है. टेंशन, टेंशन की बात करें तो सेम ही मेरे पास रोप है, सेम रोप है, तो टेंशन भी दोनों तरफ से क्या रहेगी, सेम रहेगी. ये टी है तो ये भी टी रहेगा. ठीक है, अब अगर आप बात करो, ये देखो इधर ओवरऑल जो ब्लॉक है वो 10 kg का है और इधर जो ओवरऑल वेट है वो 6 kg है, मतलब ये वेट ज्यादा है, तो दिस विल मूविंग डाउन और ये पूरा सिस्टम मूविंग अप. ठीक है, अब देखो पुली इज मूविंग अप विद एक्सेलरेशन A1, तो मूवेबल पुली हो गया. ठीक है, टेंशन तो टी है. अब ये वाला जी डिफरेंटली अगर आप देखो तो 4 kg ब्लॉक विल मूव डाउनवर्ड एंड 2 kg ब्लॉक विल मूव अपवर्ड. तो 4 kg का एक्सेलरेशन मैंने लिया 2 और 2 kg का एक्सेलरेशन मैंने लिया 3, बिकॉज दोनों का एक्सेलरेशन डिफरेंट होगा. क्यों डिफरेंट होगा, बिकॉज दिस पुली इज मूवेबल. ये कौन सी पुली है, मूवेबल पुली. ठीक है, तो आई कैन राइट दैट 2 times ऑफ A1 इज इक्वल्स टू, अब देखो विच वी हैव टू टेक पॉजिटिव, कैन एनीवन टेल which acceleration we have to take positive, A3 or A2? Anyone comment, tell me in the chat box which acceleration we have to take positive, A3 or A2? So just see the direction of pulley in which the pulley is moving. Pulley is moving up, A3 is also moving up, so A3 minus A2. This is equation 1. This is the important equation that we require to solve this. Now tension, if you will see, this is the different pulley, different string. ये स्ट्रिंग डिफरेंट है, ये स्ट्रिंग डिफरेंट, तो यहाँ पे मुझे टेंशन अलग लेनी पड़ेगी, दैट इज T1. ठीक है, तो यहाँ पे मैं टेंशन क्या लूंगा, T1. दिस इज T1, तो यहाँ पे भी क्या रहेगी, T1 ही रहेगी. बट अगर आप देखो दिस इज T, तो अगर आप FBD बनाओ ना इसी ब्लॉक का, इसी का ही, इस मूवेबल पुली का, यहाँ पे मेरे पास T है और नीचे दोनों तरफ मेरे पास है T1 प्लस T. तो मेरा जो T होगा दैट वुड बी द सम ऑफ दीज टू फोर्सेस, T1 प्लस T2, सॉरी T1 प्लस T1 विच इज 2 times ऑफ T1. ये हमेशा याद रखना. ठीक है, तो T1 विल बिकम T/2. इस तरह की सिचुएशन को और ज्यादा इजी करने के लिए आप क्या कर सकते हो, सिंस आपको पता है कि जो पुली का जो टेंशन है, पुली की साइड में जो टेंशन है वो ट्वाइस होगी इन दोनों, तो यू कैन अज्यूम द टेंशन इन पुली इज 2T, तो यहाँ भी ये भी 2T हो जाएगा. तो ये कैसे सेपरेट होगा फिर, T और T और T हम डिस्ट्रीब्यूट कर सकते हैं, तो T एंड T विल बिकम 2T. ठीक है, अभी आप देखो इधर, तो ये वाला ब्लॉक है 10 kg का है, अगर आप FBD बनाओ 10 kg, तो डाउन साइड में वेट फोर्स है 10G, अपवर्ड साइड में 2T रिएक्शन लग रहा है, किसका, स्ट्रिंग का. एंड दिस पूरा सिस्टम नीचे जा रहा है A1 एक्सेलरेशन के साथ, तो मैं बोल सकता हूँ 10G माइनस 2T इज इक्वल्स टू 10A1. दिस इज इक्वेशन नंबर 1. अभी 2 kg का आप बनाओगे तो दिस इज A1, दिस इज A2. 2 kg का बनाओ तो 2 kg का कैसे बनेगा? दिस इज 2, डाउन साइड में 2 g, अप साइड में t, ठीक है। एंड ये सिस्टम इज मूविंग अप विद एन एक्सेलरेशन a1, तो हम बोल सकते हैं, जस्ट अ सेकेंड, वी कैन से that t minus 2g is equals to 2a1. This is equation number 2. तो सिमिलरली एक इक्वेशन मेरे पास 4 kg ब्लॉक का है, और मेरे पास वेरिएबल भी कितने हैं, ठीक है, वेरिएबल भी कितने हैं, एक 10 kg ब्लॉक का आया इक्वेशन 1, एक 2 kg ब्लॉक का आया, एक 4 kg ब्लॉक का आएगा, और एक ये इक्वेशन है। तो 4 इक्वेशन मेरे पास बनी, और 4 ही मेरे पास वेरिएबल है। यू विल सी a1 a2 a3, this is a1, 2 times of a1 is equals to a3, this I have taken a3, a3 minus a2, ठीक है, a3 minus a2, ठीक है। So a1 a2 a3 and tension, these 4 variables I have, so 4 equation 4 variable we can solve it out, ठीक है, clear, चलो। So that is it for today's class. I hope that you have enjoyed today's session, the very important concept I have discussed. So please do practice the numericals in your notebook and all, ठीक है। If anyone has any kind of doubt in this chapter or in this question, you can ask. Okay, bye, take care everyone.